hydrocarbons, saturated and unsaturated. Carbon compounds contain many elements. Majority of carbon compounds contain the element hydrogen in small or large proportion. The compounds which contain carbon and hydrogen as the only two elements are called hydrocarbons. Hydrocarbons are the simplest and the fundamental organic compounds. The smallest hydrocarbon is methane, that is CH4. Combination of one carbon atom and 4 hydrogen atoms lead to the formation of hydrocarbon methane. We have already seen the structure of methane. Ethane is one more hydrocarbon and its molecular formula is C2H6. Now let us write down the line structure of this hydrocarbon. Step 1 is to join the 2 carbon atoms of the molecule with single bonds. Then, step 2 is to fulfill the tetravalency of both the carbon atoms by using the 6 hydrogen atoms in the molecular formula. Now let us draw the electron dot structure of ethane. In the electron dot structure of ethane, electrons of carbon are represented by dots, while electrons of hydrogen are represented by cross. Now let us draw the structural formula of propane. The molecular formula of propane is C3H8. This means that propane molecule has 3 carbon atoms and 8 hydrogen atoms. To write the structural formula of propane, let us join the 3 carbon atoms with single bonds, and for fulfilling the remaining valencies of carbon, let us use the hydrogen atoms in the molecular formula. From the structural formulae of ethane and propane, it is seen that the valencies of all the atoms are satisfied by the single bonds. Such compounds are called saturated compounds. Ethane and propane are saturated hydrocarbons. Saturated hydrocarbons are also called as alkanes. There are 2 more hydrocarbons that contain 2 carbon atoms, namely ethene C2H4 and ethine C2H2. First, let us see the method to draw the structural formula of ethene. The molecular formula of ethene is C2H4. First, let us join the 2 carbon atoms with a single bond. Then, let us use the 4 hydrogen atoms in the molecular formula of ethene to fulfill the tetravalency of both the carbon atoms. One valency of each of the 2 carbon atoms is not satisfied. Now, in between the 2 carbon atoms, instead of the single bond, let us draw a double bond to satisfy the tetravalency of the 2 carbon atoms. This is the line structure of ethene. In the electron dot structure of ethene, carbon electrons are represented by dots, while hydrogen electrons are represented by cross. The molecular formula of ethine is C2H2. To draw the structural formula of ethine, let us first join the 2 carbon atoms by a single bond. Now, to satisfy the tetravalency of the 2 carbon atoms, let us use the 2 hydrogen atoms in the molecular formula. The valency of each of the 2 carbon atoms is not satisfied. To satisfy the tetravalency of the 2 carbon atoms, a triple bond is required. Therefore, let us draw a triple bond in between the 2 carbon atoms and satisfy their tetravalency. This is the line structure of ethine. In the electron dot structure of ethine, carbon electrons are represented by dots, while hydrogen electrons are represented by cross. The carbon compounds having a double bond or triple bond between 2 carbon atoms are called unsaturated compounds. For example, ethene and ethine. The unsaturated hydrocarbons containing a carbon-carbon double bond are called alkenes. The unsaturated hydrocarbons whose structures contain a carbon-carbon triple bond are called alkynes. Generally, the unsaturated compounds are more reactive than the saturated compounds. Straight chains, branch chains, and rings of carbon atoms. First, let us compare the structural formulae of saturated hydrocarbons like methane, ethane, and propane. From the structural formulae of hydrocarbons like methane, ethane, and propane, we see that a single or more carbon atoms bonded to each other are in the core of the molecule, while the hydrogen atoms bonded to each of the carbon atoms are on the periphery of the molecule. The mutually bonded carbon atoms in the core are like the skeleton of the molecule. The carbon skeleton determines the shape of the molecule of a carbon compound. On joining the carbon atoms next to the other, a straight chain of carbon atoms is formed. Come, now in the table showing straight chains of carbon atoms, let us complete the structural formula of the straight chain hydrocarbons satisfying the tetravalency of the carbon atom by joining them to hydrogen atoms, and write down their molecular formula and the name of the hydrocarbon. First, there is only one carbon atom. To fulfill the tetravalency of carbon, let us join 4 hydrogen atoms to the carbon atom and complete the structural formula. From this structural formula, we get the molecular formula CH4. The name of this hydrocarbon is methane. The next straight chain contains 2 carbon atoms. Now, let us join hydrogen atoms to 2 of these carbon atoms and fulfill the tetravalency of 2 of these carbon atoms. From this structural formula, we get the molecular formula C2H6, and the name of this hydrocarbon is ethane. The next straight chain of carbon contains 3 carbon atoms. Let us complete tetravalencies of 3 of these carbon atoms by joining hydrogen atoms. From the structural formula, we get the molecular formula C3H8, and its name is propane. Straight chain of carbon contains 4 carbon atoms. Let us join hydrogen atoms to these 4 carbon atoms. From the structural formula, we get the molecular formula C4H10. The name of this hydrocarbon is butane. In a similar way, let us join hydrogen atoms to the carbon atoms in the straight chains of carbon containing 5, 6, 7, 8, 9, and 10 carbon atoms and complete the tetravalencies of the carbon atoms. From these structural formulae, C5H12, C6H14, C7H16, C8H18, C9H20, and C10H22 molecular formulae are sequentially obtained with names pentane, hexane, heptane, octane, nonane, and decane respectively. Now let us observe the carbon chain present in butane. The 4 carbon atoms can be joined with each other to form a carbon chain in yet another way. On joining hydrogen atoms to 2 of these straight chains in order to complete the tetravalency of carbon atoms, 2 different structural formulae are obtained. Both these structural formulae have the same molecular formula C4H10. As the structural formulae are different, these are 2 different compounds. The phenomenon in which compounds having different structural formulae have the same molecular formula is called structural isomerism. One structural formula of butane contains straight chains of carbon atoms, while the other structural formula contains branch chain of carbon atoms. Besides straight chains and branch chains, some carbon compounds contain closed chains, that is, rings of carbon atoms. For example, the molecular formula of cyclohexane is C6H12, and its structural formula contains a ring of 6 carbon atoms. In the electron dot structure of cyclohexane, electrons of carbon atoms are represented by dots, and electrons of hydrogen atoms are represented by cross. In this way, structural isomerism seen in carbon compounds lead to increase in the number of carbon compounds. All types of carbon compounds, whether straight chain, branch chain or cyclic, can be saturated or unsaturated. For example, propane, propene and propyne are straight chain hydrocarbons such that propane is a saturated hydrocarbon, while propene and propyne are unsaturated hydrocarbons. Similarly, isobutane and isobutylene are branch chain of hydrocarbons. But isobutane is a saturated hydrocarbon and isobutylene is an unsaturated hydrocarbon. Cyclohexane and cyclopentane are cyclic saturated hydrocarbons, while cyclohexene is a cyclic unsaturated hydrocarbon. Come, let us now see the structural formula of benzene. The molecular formula of benzene is C6H6. It is a cyclic unsaturated hydrocarbon. The structure of benzene contains a ring of 6 carbon atoms with 3 alternate double bonds. The compounds having this characteristic unit in their structure are called aromatic compounds. Millions of years ago, dead remains of organisms buried beneath the seabed over a period of time led to the formation of crude oil reserves. Now, this crude oil and natural gas are obtained from the oil wells. Natural gas primarily contains methane. Crude oil is a complex mixture of more than thousands of different compounds. It primarily contains different hydrocarbons. Fractional distillation is used for separation of crude oil, and various useful products like CNG, LPG, petrol, that is gasoline, kerosene, diesel, engine oil and lubricating oil are obtained. After knowing about the hydrocarbons, let us study about the functional groups present in carbon compounds.